Hello guys, welcome to my channel AK Tech Services. So in this video we are going to see how to make a mechanism assembly for a 4-cylinder IC engine. So for this video I have already created all the required CAD models in a part level, and I'm going to demonstrate only how to make a assembly mechanism and to run the mechanism. So let's get into the video. Before getting into the mechanism, I would like to showcase the each and every parts which I have made a CAD model. So the first part is piston, which is going to be get assembled in the engine, and it is most important part of an engine system. The second part is cylindrical pin, and the third part is circlip. Fourth part is connecting rod. Fifth part is crankshaft. Sixth part is oil sump, and seventh part is engine block, and eighth part is piston rings, and the ninth part is oil rings. So in this mechanism we are going to use these kind of the parts, and finally we are going to get assemble a gear in the output of the crankshaft as well. So let's get into the mechanisms. So first I'm going to create a new part, and for this I'm selecting an assembly workbench, renaming it as engine assembly. Just click enter here. So a new engine mechanism assembly workbench has been created. So before importing the parts, I would like to have the axis lines. So I'm selecting right and top, creating an axis line, as well as top and front, creating an axis line, as well as right and front, creating an axis line. So here we can able to see we have three different planes, a coordinate system, and three different axis lines in all X, Y, Z directions. So let's get into the assembly. So click on the assembly command. I'm getting the engine block part as the first part inside this. For this, I'm going to give a defined connection as default. So I'll just click OK here. So the engine block has been assembled in default position where the CAD model has been done. So the second part I'm going to give here is the crankshaft. So but before getting the crankshaft, I would like to have a plane which is going to fall on the axis of crankshaft. So let me measure the distance from the top plane of assembly system to the axis of crankshaft. It is showing 450 mm in sharp. So I'm going to create a plane with reference of the assembly top plane in the distance of 450 mm and click OK here. Next, I'm going to create an axis line which is applicable to the front plane of the assembly and the top plane which we have drawn right now. So we can able to see an axis line has been created which is highlighting in orange color, which is parallel to the axis line of crankshaft. We hide the points and coordinate systems. The next part we are going to get assembled is the crankshaft. So just click on the assembly button, select the crankshaft part, and for the crankshaft part is going to be run in the mechanism simulation. So please ensure you're going to give a pin connection for crankshaft. So in connection type, I just drop down to the user defined and change it to pin connection. In pin connection, we are going to define two different connections. One is for the axis alignment and one is for the translation. So in axis alignment, I'm selecting the center axis of the crankshaft getting assembled with the center axis which we have drawn just now. This will get coincidence. And the second thing, we are going to get assemble the translation movement where I'm going to connect the second cylinder plane to the assembly front plane where it perfectly matches. Okay, in this I would like to have a small modification on the plane which we have created. So the axis line is here. So I would like to regenerate this, or else I would like to modify this since there is a slight mistake in this. So I'm selecting this and I'm remodifying this axis and just click OK. So now you can able to see the crankshaft has been assembled to its position with reference of axis orientation and translation motion to arrest this. Now this crankshaft has 1 degree of freedom in free where it is going to be rotate. So to get assemble the next part, I'm going to change the view appearance of engine block as a glass texture, where it will be very helpful to view the next upcoming parts. So the next part I'm going to assemble here is the connecting rod. So click on the assembly button. I'm selecting the connecting rod. For connecting rod also, I'm going to use pin connection since it is going to be a part of mechanism simulation. So I selected the pin connection. I'm selecting the surface of the connecting rod and getting assembled with the surface of crankshaft here. So the axis is got aligned. The next thing is we need to make it a connection between the plane to arrest the translation motion. For that, I'm selecting this side plane to the side plane of crankshaft and just click OK here. Now the connection has been enabled. The only degree of freedom is on the rotational motion. In the same way, I'm going to reassemble all four connecting rods once again. So just click on this, select the connecting rod, change it type to a spin connection, select the circle of connecting rod, select the crankshaft surface, and for translation select the side plane of connecting rod to side plane of crankshaft. So this is how the second connecting rod has been assembled. I'll just hide this engine block so it will be very easy to understand. Third, and I'm getting another connecting rod. Same way, I'm changing to pin type. I'm selecting this surface to the surface of crankshaft. And for translation, I'm selecting plane to plane. Since there is no any plane here, I'm going to select the middle plane with the references as distance of 125, or else you can select the surface between the crankshaft and connecting rod. I'll just remove these connections, these references, and I'm selecting the surface to surface, the distance as 5 mm. That's how I have made a CAD model for this. Now in the front view, you can able to see there is a even gap between the second connecting rod to the third connecting rod as well. The fourth connecting rod I'm going to assemble. For this also, I'm going to select the pin connection, select the pin type, and click on the crankshaft. As well as the same, select the surface of the connecting rod to the surface of crankshaft with the distance of 5 mm. So the connecting rods has been assembled here. The next part we are going to assemble is cylindrical pin. So click on the assembly button and select cylindrical pin, or it is called as piston rod. So this also going to have same pin type connection. So I'm selecting the pin type. I'm selecting the surface to the another end surface of connecting rod. For the translation motion, I'm going to have a connection between the right side plane to the right side plane of connecting rod. So just click OK here. In this way, we are going to reconnect all three piston rods here. Once again, I select the piston rod. I'm switching to pin connection. I'm selected the surface to the surface of connecting rod. And for the translation, I'm selecting the side plane to the side plane of connecting rod and click OK. Once again, I'll go to assembly, select the piston rod, change it to pin type, select the surface and select the surface of connecting rod. And for the translation motion, I'm selecting the plane to side plane of connecting rod and click OK. For the fourth piston rod, the same way, I'm selecting the pin connection and selecting the surface of connecting rod. And for translation, I'm selecting the plane to plane. So this is how four connecting rods or piston rods has been get assembled. The next part which we are going to connect here is the piston. So click on assembly, select the piston part. For piston part, as of now, we are going to give one connection which is pin type connection. Later we are going to give second connection as a slider that we will see how to give. So first I'm selecting pin connection. On pin connection also, I'm selecting the axis to the axis of piston rod to be as a coincidence. And for translation, side plane of piston to the side plane of piston rod as a coincidence. In the same way, rest of three pistons also going to get assembled. So select the pin connection, select the axis line of piston and axis line of piston rod. For translation, select the side plane of piston to side plane of piston rod. So the third piston, change it to pin type, select the axis to the select axis of piston rod and select the plane to the plane of piston rod. And fourth piston, the same way, switch to pin connection, select the axis to the axis of piston rod, and for the translation motion, select the plane to the plane of piston rod. So this is the single one type of connection which we have given for the piston. In the same piston, we need to give second set of connections that we'll see how to make it next. So before going to that, I'm going to have an assembly of piston rings. So go to assembly, select the piston ring. For piston ring also, I'm going to have the same pin connection between this part to the surface. And for the translation, I'm going to select the surface to the top surface of this with a distance of 0.25 mm. That's how I have made a design for piston ring. So in the same way, we are going to reassemble all the piston rings in the quantity of 8, and each piston has 2. We'll select the pin type connection, select the surface to surface, and the second connection, surface to surface with the distance of 0.25 mm. So for the first piston it is done. Next, second piston. For the second piston also, I'm going to select pin connection, and for the translation motion, I'm selecting the surface to surface with the distance of 0.25. So once again, piston ring with pin connection here to here, and surface to surface with the distance of 0.25. Just click OK. So we have completed for 2 pistons. Just 2 more pistons are pending. Let's continue the same work once again. Piston surface to piston surface, and the top surface of the piston ring to the surface of piston with a distance of 0.25. Assembly piston ring, surface to surface, and surface to surface with a distance of 0.25 mm. So the last final piston, select the piston ring, select the pin type connection, and for the distance, surface to surface with the distance 0.25. The last and final piston ring to the last and final piston, go to pin connection, select this, select the surface as well as select the top surface to surface with a distance of 0.25. Next, we are going to assemble the oil rings. So I'm selecting the oil ring here. Oil ring also follows the same concept of we assemble the piston rings. So I'm making the pin connection, axis to axis alignment, and for the translation, I'm selecting same way the top surface to the oil surface with a distance of 0.25 mm. the second oil ring, switch to pin connection, and in surface to surface distance as 0.25. Third oil ring, same way, select the pin type, connect it to the surface, and for the translation, surface to surface distance as 0.25. So the last and final oil ring we are going to get assembled the same way of piston rings. Change it to pin connection, select the surface to the surface of piston, as well as select the top surface of the oil ring to the surface of oil ring area with a distance of 0.25 mm. So here we have connected all the piston rings and the oil rings applicable for this assembly. Next we are going to have a assembly connection between the piston to the engine block. So I'm enabling the engine block here. Once again I go back to piston connection, have a new set of connection, make it to a slider, and in slider I'm going to assemble the surface of the cylinder is coincidence with the surface of the piston, as well as for the rotation I'm going to have a alignment with the planes to plane. So I'll select the front plane to the front plane of the assembly and just click OK here. So please make sure this is one of the important step we need to follow in the mechanism assembly. In case if this is not, then the engine mechanism assembly won't work properly. So I'm repeating for the second piston, edit definition, go for a new set of connection, change it to a slider, and select the surface of the cylinder to the surface of the piston, as well as for the translation, select the front plane of the piston to the front plane of the assembly to be aligned in this way here, and just click OK. So the third piston, click on the edit definition, add a new set of connection and make it to a slider. Select the surface of the cylinder and surface of the piston to be get coincidence, and for translation select the front plane of the piston to the front plane of assembly. So whenever I'm giving this slider connection, you can able to see a slight movement has been taken in the piston. So that is what going to get align the piston with the holes in the cylinder. Next, the fourth piston, once again I'm going to have a new set of connection in the slider mechanism, and I'm selecting the surface of the cylinder to the surface of the piston and plane of the piston to the plane of the cylinder, and you can see there was a slide connection will be there. Yeah, so then the next part I'm going to assemble here is the oil sum. So to get the oil sum, I'm going to make the engine to be as a aluminum body, and I'm going to bring the oil sump here. So for the oil sump also I'm having a rigid connection. Why it doesn't has any mechanism in that. So I just make coincidence with directly on the surface to surface with engine block, and there is a provision for the crankshaft output. The final part I'm going to assemble the gear. Gear is also I'm going to have for a pin connection where it is going to showcase how the crankshaft is going to be rotated. So I'm making to pin connection, select the surface to surface connection, and for the translation the surface to the surface as a coincidence. So for a better understanding I'm going to change the color of the gear in metallics. Yeah, I would like to change the position of the gear. So I'm going to remodify the translation surface in the crankshaft from this end to this end and flip the direction. So this will be looks nice when we are checking for the mechanism. So once again, I'm getting back the material of engine block to the glass structure where we can able to see the mechanism, how it is going to work. So for this, I'm going to have a oil sump also to be as in a glass structure. So it will be even more clear and better understanding when it runs with the mechanisms. So to add a mechanism, we are moving to the applications workbench. In this, we are going to select mechanism tab. In mechanism tab, I'm going to select a servo motor, and the servo motor is going to be assigned to the crankshaft which we have added here. And please ensure the servo motor has been added to crankshaft just by highlighting it. In profile details, switch the driven quantity from angular position to angular velocity, and the coefficient of angular velocity as 25 degrees of freedom of 25 degrees of second. So I'm going to have this kind of a servo motor here, and I'm going to run the assembly now. So click on the mechanism analysis. You can able to see analysis definition tab here where the start time is 0 and the end time is 10. I would like to increase the end time as 100 and click on the run button. So once you click on the run button, you can able to see the crankshaft will rotate. Based on the crankshaft rotation, connecting rod also will rotate, try to rotate, and that it will make a movement, sliding movement in the piston just by slider engineering connections. So just clicking on the run button, and here you can able to see how it works. So this is going to run for 100 frames. Since the speed of the velocity I have given is like 25 degrees per second, so it will be a very minimal speed. Once it's done, I will change the velocity value from 25 to some other value, and I will showcase how the gear mechanism will work. Let it run for a minute. Within a minute, this mechanism run will be done. Even you can able to see how the piston is moving exactly on the axis of the holes in the cylinder block, and it is not touching the exact top of the cylinder, as well as it is not exactly touching the bottom of the hole as well. This is the area which is called as a swept volume, and the clearance above the swept volume in the top is called as a clearance volume in the top dead center, and the same clearance volume in the bottom dead center. The total length is called as the cubic capacity, or called as a cc of the engine. So now the mechanism is done. Now I'm going to have servo motor with a velocity speed as 100 degrees per second, which is 4 times as per the current value. Once I am click on the mechanism analysis, I'm changing the frame count as 50 and click on run. So now you can able to see how faster the mechanism is running. So this is how a 4-cylinder inline engine is going to work. Either it is a diesel or a petrol. The entire fuel system and the exhaust system will change based on the condition. But just for the engine, crank, and the connecting rod mechanism, I would like to demonstrate here. This is how it's going to work. So I hope you guys have enjoyed the video and you guys have learned how to make a mechanism for 4-cylinder IC engine. Either it is a petrol or diesel, you can make in this way. So next video I'm going to get in the even more interesting one. So please subscribe to my channel, and if you like this video, please like, mention your comments, and you can post your doubts, questions also in there. And if you like this, please share it with your mechanical friends who is very much interested in mechanical CAD designs. So thank you guys, thank you so much for watching the video, and we'll see you in the next one. Bye bye.